Hi friends, in this video I'll explain single linkage hierarchical clustering by solving a numerical problem. Let's solve this question where it is asked to find the clusters using single linkage hierarchical technique and draw the dendrogram. And it is given that these are the 5 points P1, P2, P3, P4 and P5, and their x and y coordinates are also given. These are drawn in the 2D space between x and y as P1, P2, P3, P4 and P5. The very first step here is to find the proximity or the distance matrix, which will give us a matrix of distances between every point and the every other point. For example, to find distance between point P1 and P2, I am using Euclidean distance and the formula is this. Let's say the coordinates of P1 as x1, y1 are 3, 1 and coordinates of point P2 as x2, y2 are 7, 9. So using this formula, I can find the distance between these 2 points as 7 minus 3 square plus 9 minus 1 square under the root, which will give me 7 minus 3 4 square as 16 plus 9 minus 1 8 square as 64 under the root, which is approximately equal to 9. And I can record this way each and every distance of all the points with every other point. So distance between P1 and P2 I have calculated, which is coming out to be 9. P1 and P4 is 6, P1 and P5 is 11. This way you can pen down this proximity distance matrix. This will be a symmetric matrix. Now from this distance matrix, you have to look for the most similar pair of clusters. That means the lowest distance you have to find out, which is 2 here between point P3 and P5, and these 2 points P3 and P5 will be merged into a single cluster, because initially we started with P1, P2, P3, P4, P5 as individual clusters, as 5 clusters, and as between P3 and P5 distance between the two is lower, so we'll merge them into a single cluster. Now after merging the two P3 and P5 clusters, you have to compute the distance between this new cluster and each of the old cluster using single linkage or minimum distance clustering. Here comes the role of single linkage clustering. In the matrix notation, from row and column of this matrix, just remove P3 and P5 and merge them into as one, like this, P3 comma P5. Same way P1, P2, P4, then P3 comma P5, and then the distance between P1 and P1 will remain 0, P2 and P1 will remain same. For P4 it will remain same as 6, 5, 0. And to write the distance between P1 and P3, P5, write the minimum of the 2, 3 or 11. So 3 is minimum. Then between P2 and P3, P5, you will have to write the minimum of 7 and 10. So 7 is the minimum. Then between P4 and P3, P5, 8 is the lowest, and between P3 and P5, 0. So this way your matrix will be formulated. Now we have to repeat steps 2 and 3 until all the points are merged together into a single cluster. Here, looking at the matrix, we find that 3 is the lowest distance, which is between point P1 and P3, P5. So these two clusters will be merged as one cluster. So removing first column and merging it with the last column, and removing the first row and merging it with the last row, we'll have 3 by 3 matrix. And here we'll use the single linkage clustering, wherein to write the distance here, you will have to look at the lowest of the two, 9 or 7. So 7 will come here, and for distance between P4 and the new formulated cluster, you will have to look at the lowest value between 6 and 8. So 6 will come here. Now again, from this matrix, find out the lowest distance, which is 5 here between P2 and P4. So we'll merge these 2 points together and my new matrix will look like this. And I have to find out this distance, which is between P2, P4 merged cluster and this merged cluster. So this will be minimum of either 7 or 6. So out of 7 or 6, I'll write 6 here. So this is my final matrix. Now at the last step, this 2 by 2 matrix will be reduced to 1 cross 1 because this cluster will be merged with this cluster and we are left with the complete whole cluster. Now the task is to draw the dendrogram. So you will have to mark all the individual clusters at the bottom. Then at the very first instance, we merged cluster 3 and 5 together because these were the two closest points at a distance of 2. After this, we merged this with point P1. So here is the point P1, which is merged at a distance of 3. After this, we found that 2 and 4, cluster 2 and 4 were close together and these two were merged together at a distance of 5. And at the last step, as you can see here, these all were merged as a single cluster at a distance of 6. So this is how my dendrogram looks like. This dendrogram is made based on the distances between the clusters, and if I mark a horizontal line at level 4, that means at a distance of 4, I can say that this horizontal line is cutting the vertical lines at 3 points. So there are 3 clusters at this level, cluster 1, 3, 5 and cluster 2 and cluster 4. And at level of 5, it is cutting at these 2 points. So that means there are 2 clusters, one containing points 1, 3, 5 and the other cluster containing 2 and 4. So this is how we can make use of dendrogram to infer the number of clusters present in the data set. Thanks for watching.